Hi, it's Miss House. Before I do some exercises from 7.1, I want to go through the basics of the antiderivatives so that you get an idea of what's going on. So the definition of an antiderivative: if the derivative is a certain function, then the function whose derivative was taken is called the antiderivative. So what that means is that we've taken a derivative and we're going to go backwards and find the original function that we took the derivative of. Now what this is saying is that if these two functions have the same antiderivative, okay, there's a constant that separates them. And they've drawn some pictures here to show you. If you have three functions that are identical except for the constant, those functions are going to be in the same place except for they're going to be shifted up or down. So if the antiderivatives differ by a constant, there's no way to know what that constant was, is what we're saying. Because remember, when you take the derivative of a constant, you get 0. So how do we know what that constant was? Because there's an infinite number of constants that could be added onto a function, and all it does is take that function either up or down. So I'll give you an example. Let's look at this graph. So this is very similar to what they have there. So I've got y equals x squared. Now remember, when you take the derivative of that, you get 2x. Well, what about y equals x squared minus 4? Well, when you take the derivative of this, you also get 2x, because when you take the derivative of that negative 4, it's going to be a 0. So how do you know which one of these functions you were talking about? That is what this rule is all about. They differ only by a constant if the two functions are the same except for the constant. So here's what we do to fix that. If you've taken the derivative and you've gotten a certain function, then the antiderivative, and here's our symbol for antiderivative, it's a long skinny s, okay? That's what it looks like. When we take that derivative, we get the original function, but we have to add a constant c, okay? So since we don't know the constant, we just call it c for these purposes. Now later on, if we know more information about the original function, we can figure out what this constant is. But until we're given additional information, this indefinite integral, which means we don't know exactly where the function was located in the plane, okay? We know that the function might look like this or this, but we're not sure which one it is. So we have to add a constant, and we use the plus c to indicate that we know that there was probably a constant there, we just don't know what it is. Okay, that's all it means. Now, some of the rules for taking antiderivatives. Now remember, we're going backwards to find a function whose derivative was taken. Okay, that's called the antiderivative or the integral. So here's the power rule. Remember, when you do a power, you multiply by the power and you subtract 1. That's when you take the derivative. You multiply by the power and you subtract 1. So what do we have to do to find the original function? We have to add 1 back to the exponent and divide by the exponent. Because remember, we multiplied by the exponent. Going backwards, we have to divide by the exponent. And we have to always tack on the plus c here. Okay? Now, the exponent can't be -1 because you would get -1 plus 1 or 0 in the denominator. So there's another rule for that later on if you have an exponent of -1. We'll deal with that later. But for any exponent other than -1, you add 1 to the exponent, excuse me, and then you divide by whatever that exponent is. All right? Now here's the constant rule and the sum or difference rule. This says that if you've got a number that's multiplied by a function, you just bring it out to the front. Okay? You don't have to worry about this constant. Just factor it out, bring it to the front. And we'll do that sometimes and it just makes it much easier to do. So bring your constant out front, then do your integral. That's all that says. And this says if a function is made up of multiple terms, added or subtracted, you just take the integral separately. Just take the integral separately of each of those parts that are added or subtracted. Okay, so you can bring a constant outside, and if it is made up of multiple sums or differences, now we're talking about adding and subtracting, we're not talking about two functions that are multiplied, we're talking about adding or subtracting, you can separate the terms that are added or subtracted. And I haven't mentioned, but this little dx is called the differential, and this means that the derivative was taken, and you'll see this every single time you're doing integration. And you need to remember, with the integration symbol, you have to have the derivative with respect to x. Is what that means, that we're going to, that the derivative with respect to x was taken, and now we want to go backwards. So you look for that little dx differential. All right. Now, exponential functions, okay? If you take the integral of e to the x dx, it's e to the x plus c. Just like when you take the derivative of e to the x, you get e to the x. When you take the integral of e to the x, you also get e to the x. But you have to remember to add the constant, because remember, let's go back to our graph. If I have e to the x here, e to the x, and then I have e to the x, e to the x minus 4. Look, once again, these two functions have the same derivative. They're both e to the x. So we don't know if a constant was added or not. So with all indefinite integrals, okay, that means we don't know anything additional about the function. We just know we've got to go back and find the original function. We have to add the plus c. All right. If it's e to the kx, okay, it will be e to the kx divided by k plus c. So if that's e to the u, when you take the derivative, it's e to the u and the derivative of the u. So that's why you have to divide. If this is like a 2x, you ended up taking the derivative, you multiplied by it, so you got to divide by it to go backwards. Again, you can't have 0 in denominator, and that's what this k is not 0 means. Okay. Now, for exponential functions with a positive base, like 2 to the x, okay, and a base of 1 is not allowed either, because 1 to the x and 1 to the 1 and 1 to the 2 and 1 to the 3 and 1 to the 4 are all the same. Okay, so we're not talking about a base of 1. The derivative is a to the x divided by the natural log of a plus c. So for an exponential function where the base is a positive, okay, and not a 1, the derivative has been taken. So to get back to the original function, you have to do a to the x divided by the natural log of a and then add c. Now there's a proof for that, but we're not going to go into that for this class. We're just going to know that we have to take the a to the x and divide it by the natural log, and always remember to add the c. And the same thing, if the exponent is not a plain x, but it's a 2x or a 3x, you have to also divide by that k, just like we did up here when it was e to the kx. Okay, these are very, very similar, but their integrals are slightly different. Okay, if it's a base of a, you have to divide by the natural log of a. All right, and now the last one is, what do we do when we have an exponent of -1? Remember, when we did the exponent rule up here, we said that the exponent cannot be -1 for this rule. So we have a rule for it that says, if you have x to the -1, that means 1 over x. Now, if you remember, when we took the derivative of the natural log, it was 1 over x. So that's why this is the natural log. And we put absolute value around this x to indicate that this has to be a positive value. You cannot take the log of a negative value. Think about what the natural log means, okay? The natural log means a base of e. E is a number, it's about 2.7. When you raise the number 2.7 to any power, it's going to always come out positive. So the natural log is always going to be a positive number, and that's what these absolute value bars mean. Okay, now let's do a few problems. Okay, just apply these rules. All right, so here I have the function that's a constant function, and I want to take the integral of it, and notice there's a dx here. All right, so I've got the integral of 11 dx. Okay, so its integral is going to be 11x plus c. Now think about this. What's the derivative of 11x? It's 11. But what's the derivative of a constant? It's 0. So we don't know if this 11x function had a constant added or not. So we write 11x plus c. Okay. Now here's the sum or difference rule. We have the integral of 10x plus 4 dx. I'm going to split this into different parts. Each term, that's 10x dx plus the integral of 4 dx. Now remember, if there's a constant in front, it can come outside. We're going to do the integral of x dx plus the integral of 4 dx. So those constants come outside. So this one has an x. We need to use the power rule. Okay, this is an x to the 1, so we need to add 1 and divide by that. So this is going to be a 10 and an x squared divided by 2. Now once we have taken the integral, we don't need this dx anymore. Plus 4, if it was a constant, the function was just x, right? Because what's the derivative of 4x? It's 4. And then we need a plus c. Now we don't have to add the constant twice, we just add the plus c. And then we've got to reduce this. 10 divided by 2 is 5. X squared plus 4x plus c. Now, how do we check this? Well, let's take the derivative. Power times the coefficient would be 10x. Well, there it is. The first term is a 10x. What's the derivative of 4x? It's 4, right? So there's our 4. And we don't know what the constant was, so we write c. So the integral of 10x plus 4 dx is 5x to the second plus 4x. Now let me show you what happens if you don't put the plus c. Okay? Apply the constant rule. You don't get a good hint about it, so it's not going to tell you you need to add the c. So you got to remember to always add the constant. Now we got it right. Okay, this is a similar problem. All right, so let me get a new clean board here. Okay, I've got the integral 3x squared, and I'm going to go ahead and separate it. Each term needs a dx. That means I'm going to take the integral of this and find the original function whose derivative was taken. Minus integral 6x dx plus integral 4 dx. Now, I could have put all those constants out front, but I'm not even going to worry about that. I'm just going to add 1 to my power, divide by my power, add 1 to my power, divide by my power, add 1 to my power. Well, there's x to the 0 here, right? That means 1, so that's not there. And then I'm going to divide by my power, which is 1. Now notice, 3 divided by 3. 2 exponent divided by 2. 1 exponent, we don't really even need to have that. Now, don't forget, plus c. Then I'm going to go back and clean this up just a little bit. All right, it's going to tell me it's not reduced if I do leave it like this. So x to the third minus 2 goes into 6, 3x squared plus 4 plus c. Now think about taking, that's 4x by the way, sorry. Taking the derivative of this should give us this function here whose derivative has been taken. So remember, power times the base, power minus 1 would give me a 3x squared. Power times the coefficient would be 6. Minus 1 would give me 6x. This 4x, the derivative would be 4, and then plus c. So you can always use your derivative rules to go backwards. So I'm going to enter this, x to the third. Whoops, let's see, let me go back. X to the third minus 3x to the second plus 4x plus c. And I believe if you put a lowercase c, you'll also get credit. I don't think it's going to take off if you put lowercase. It shouldn't. Okay, so now we have one that has roots in it. Okay, we have to remember when you have a root to write it with a fractional exponent. So I'm going to go ahead and split it apart. Integral 15 x to the 1/2 dx. Every time you have an integral symbol, you must have the dx saying that a derivative has been taken. Plus integral square root of 2 dx. Now this one is a constant, so this is just the square root of 2x. And I'm going to go ahead and put my plus c. Because remember, it doesn't matter what this constant is. If it's a coefficient, when you take the derivative of this guy, you just write the coefficient. So don't let that confuse you. I'm just going to leave that as a square root of 2. Okay? You can write it 2 to the 1/2, but you don't have to. But this one I do because I've got to add 1 to this and divide by it. All right, so let's take a second to go down here and divide by a fraction. Let's say I've got 3 divided by 1/2. That's 3 with this symbol divided by 1/2. And if you remember, you have to change this and flip this. So anytime you're dividing by 1/2, you're really multiplying by 2. Okay? Okay. So I've got 15 x 1/2 plus 1 divided by 1/2 plus 1. So what's a half plus 1? Okay. Well, that's 1 1/2, right? Which would be 3 over 2. So we're not going to divide by 3 over 2. We're going to multiply by 2/3. So I'm going to have 15 x to the 3/2. If you've got that TI, you can use that ABC key to add your fractions. Just put in 1 in this fraction key, 2, and then plus 1, and it'll give you 1 1/2, and you'll have to change it to 3 over 2. You press second and the fraction key, okay, if you need to do that. Let's see, so that's this done. We've got to divide by 3/2, which means we're going to multiply by 2/3. Okay, so I've got to clean all this up. Yes, I've got a fraction to deal with. It makes it a little bit harder. This part doesn't change. Look, the 3 goes into the 15 5 times, and 2 times 5 is 10. So I've got 10 x to the 3/2 plus the square root of 2x plus c. Now let's go back and let's take the derivative of that. Right? Let's take the derivative of this to prove that we got the right answer. Okay? So what is the derivative rule? You take the power, 3/2, times the base, the power minus 1, plus integral of any plane x. Remember, that's a 1, so you do 1 times the square root of 2, right? So that's just square root of 2. Whatever that constant was, the reason we don't see it, it's not a c there, it's a 0, right? Because we take the derivative of a constant, we get 0. That's why we need that c. Now, what is this? This is 3 over 2 times 10 x to the 1/2, because 3 over 2 minus 1, 1½ minus 1 is a half, and then 2 goes into 10, and we get 15 x to the 1/2 plus the square root of 2. So look, same thing. X to the 1/2 is the square root of 2. So the fractions can be a little bit tedious, but use your calculator to do that. Plus, you're going to get square root all the time. So look, let's do this. You're going to get the square root of x all the time. So the square root of x is x to the 1/2. So if you remember, when you take the integral, just kind of memorize this. You got to have that dx. When we take the integral of x to the 1/2 dx, that's going to be x to the 1/2 plus 1 divided by 3 over 2. It's always going to be 2/3 x to the 3/2. So if you just kind of memorize that the square root of x always has an integral of 2/3 x to the 3/2. And then you don't have to worry about, you know, doing the fractions over and over and over, because there you go, you got it. All right, so let me finish this. This was 10x to the 3/2 plus the square root of 2x, and don't forget your c. And also, look, I'm going to put a lowercase c just to prove it, but look, be careful. This x is on the outside of that square root. And see, it let me take, let me go back. It let me put in a lowercase c, so don't worry about that. Okay? All right, so let's go to the next one. All right, so here we have some multiplication. And we haven't talked about any rules for multiplication. There are some rules for how to do this, but what we're going to do is just apply the math we already know. All right, if I've got 8x squared, x cubed plus 9 dx, I can go ahead and distribute this, and that's what you need to do. 8x squared times x cubed is 8x to the 5th. I'm going to keep my parentheses here for just now. 8x squared times 9 is plus 72 x to the 2nd. Now, I kept the parentheses because each of these, the dx applies to each of these. So if I want to separate them, I've got to be sure that I put that differential dx with each term. And now I can use the reverse power rule, right? So we're doing the integrals. We've got to add 1 to the exponent and divide by it. So that's going to be 8x to the 6 divided by 6 plus 72x to the 3rd divided by 3 plus c. Don't forget your plus c. And this 8 over 6 reduces to 4 over 3 x to the 6th plus 3 goes into 72, 24 x to the 3rd plus c. And if you want to check it, take the derivative of it. 4 over 3 x to the 6th plus 24 x to the 3rd plus c.